let's look at how the histogram function works in R and how we can do some different options with it to give us different types of outputs. The first thing I'm going to do is create an object. I'll call it histo. And I'm going to use the histogram function, which is just hist. And I'm going to put in the rainfall data. So rain.data. And then I access that column of the rainfall depth. So the first thing we can do is just put it in an object. It's going to plot it, but it's also going to give me this object right here. So here's my new histogram object. It's got a lot of stuff inside. So all those dollar signs reference, in this case, these are vectors, right? So 1 to 8, 1 to 7, 1 to 7. The breaks, this gives me, let's just go ahead and plot that out or print that out. So I'm going to do histo $ breaks. And I'm going to run that line by doing Control Enter. Oh, breaks. And this gives me, what do you think these are, the breaks? What does that mean? If we look at, what's that? The bins. Yeah, so here's the histogram. We'll run it again. It goes from 35 to 70. Breaks gives me just the bin value. So it breaks the data up into those values. So it's just a vector representing these bin endpoints. I also have mids. Mids, that's going to be the midpoints of the bins, right? So 67.5 is between these two values. I have counts and I have density. So the default for a histogram is just to do the frequency. How many counts or how many observations fall between these two bin values? But the frequency is not a probability value. So I've got a couple options. If I want to plot the relative frequency, I can go look at, I can do $hist in the command and press enter. And then it tells me all the different arguments. So I can feed it breaks. The histogram gives you breaks automatically. I think I tell you to give it different bin sizes. So that's something you can do. And it has to be, well, it doesn't have to be anything. You can give it 2 values and it'll just give you 1 bar. You can give it 3 values and it'll give you 2 bars. So you can give it different break values. Frequency, and by default, I think this is false. So let's try frequency. So I'm going to do histogram, and then I'm going to do frequency equals true. You can either type true out or just spell it. That didn't change it. Let's try frequency equals false. Okay. So now it's plotting density. So I said frequency equals false. So instead of giving me the frequency or number of observation in each bin, it's plotting the probability density. It already calculated that, and you can see that there's a density term right here, or density vector. And this is where you're going to have to wrestle with the math. What is density? What does that actually mean? We're going to do one step before we get there, though. So I say in this lab, I say convert the counts vector to relative values by dividing by the total number of counts, the total number of observations. Okay, so I've created this object histo, and you can see that counts, by default, it's going to plot counts. If I go back here and I just take that out, it's going to plot frequency or counts. Now I'm going to change that, and I can actually go in here and change it. So if I go histo counts, I'm going to change that. I'm going to give it a new function or a new set of values. How do I calculate the relative frequency? So right now it's just giving you the total value in each bin. How do I do the relative frequency? So the total number of observations, right? So I'm going to take the counts. So this already divided it up. It binned it up and gave me the counts. And then I'm going to divide it by, there's a couple ways I could do this. How do I find the total number of observations of this data frame, of this data set? Yeah, but how would I code that? I could just take that number in looking at it, but how would I do it using functions? So that's kind of automated. If you put 29 in, that means you're kind of hard coding that value in. Say I ran this code next year, now I have 30. I want to automate these things. Yeah.
Use histo $sign counts.
Okay. So the counts should be, they should sum up to everything, right? And I can just highlight that and press Control Enter, and it gives me 29. So that's one way to do it. Another way to do it is this function called nRow. This gives me the number of rows in a data frame. So how many rows in the data frame? 29. So there's a lot of ways you can do it, but those are two ways. Okay, so if I do that, then it's going to if I do that, then I'm going to plot histo again. Okay, so I made the histogram. I'm going to change the counts to relative frequency. And so you can see that it updated that vector in there. And then I'm going to plot it again. And so now I get frequency. So if I sum those up, what should they equal to? Let's find out. I get 1. Great. Okay, so now that we've stored frequency in there in that histogram. So if I look back here, the counts is no longer an integer, it's just that relative frequency. I can convert this now to probability density. And the way to do that is by bringing the bin width in. If I look at a histogram and I have a density histogram, probability density, what do we remember about the relationship between density and probability? If I think about, if I were to fit a smooth curve over this, and I integrated that curve and I got the area under it, what is that area equal to? It's equal to 1. So then if I think about, I have a histogram with probability density as the y value, how do I calculate the probability under the area of this histogram? So I've got density values as y. So I need to multiply each of these y values by the bin width. And so that gives me the area of each of these little rectangles. So taking that kind of in the inverse sense, then if I have relative frequency, so histo counts, right? So now histo counts as relative frequency. What do I want to do with the bin width to convert to density? So in this case, I multiply, but now because I want to create these probability density values, I'm going to divide by the bin width. And so that would be, if I want to code it, I can do so the breaks gives it to me, but I want it to be just a vector. Yeah, I guess I could. The breaks, that should work, because counts as 7, and then if I just do the difference of the breaks, that's going to give me 7, right? So you can use this function diff histo breaks. And now I'm going to run this just to see what it gives me. So it gives me 1, 2, 3, 4, 5, 6, 7 5s. And if I divide 7 relative frequencies by 7 5s, then I'm going to get density. Okay, so now I've updated counts to be probability density, and I'm going to compare that with the actual density that it calculated on its own, right there. So histo counts and then density counts. And you can see that it's the same number. So boom, 0689, boom, 0689. So we went from counts to relative frequency by just dividing by the count by the total number of observations. And then we went to density by dividing by the bin width. And then I can check if density times bin width equals 1. So if I do sum of my histo counts, and I'm recording this, I'll post this, you guys can follow up with, I know you've been dealing with stuff. So if I sum that up and I multiply it by the bin width of 5, that should equal 1. And it does. So all I took is all those density values and I multiplied them by the bin width, and we got 1 back out. So we got the area under this is equal to 1. Okay, so that is essentially what we're doing in the lab. There's some, I have you play around with logical arguments here just to do that. So follow along with that, and hopefully this lab won't take you too long. I have it pretty short. We essentially just did the lab. So